Hello, gentlemen. Thanks again for the awesome chat this afternoon, this evening, wherever you were. It's excellent stuff. Always learn something. Terrence and I had a quick chat after the call there and thought we might try to uh, build a model for you live, showing you the steps involved in creating the model used in the paper. Basically, how I did it. So, let me turn on some numbers for you. All right, so the round cube, I start with a round cube, and it has a diameter of 1.618. And then I start, second thing is to add in a harmonic force, which is a point at the point center of the sphere, just a harmonic there with a rest length to match that radius of 1.618. And then the next step is to add a particle system. In this case, I added 1,000 particles with a mass of 1 and 0 velocity, so that when I start them, they would just sit there if the harmonic wasn't acting upon them. So they have no velocity unto themselves, no energy. So it's nothing but the harmonic oscillating them. And as you would predict, when I just run that, I'll turn on the particles here so we can see them. They're in blue. They are set to, for the color, they're just going to be halos, and the color is going to be velocity, where blue is at rest, like right now, and red is at maximum velocity, with a size of 0.2, just so they're quite small. Okay. Then when I run that as a simulation, see, as you would expect, this is just to show it works for physics in the game engine. It's just going to sit there and collapse on itself, bounce back and forth. Let's go back to the harmonic real quick here. -4. Right. Okay, so the next step is to duplicate that on the z-axis by the radius. Okay, and this negative was -4 in the center because it's an attractor. That's the positive bias to the ends, like it's a pull. It pulls all the time. Okay, now we're going to add the electron, what we're calling the electron Gaussian spheres, the charged spheres. And I'm going to have them have a value of 1 and a 1.414 rest length, square root of 2. Take a look from the right side. Duplicate rotate on the x-axis, the 109.47 degree tetrahedral angle. Take the top view orthographic, duplicate rotate on the z by 120 degrees twice. So now we have the 5 spheres that we're looking for in the tetrahedral tetrahedron formation. And with a bit of luck, when we hit the simulator on that, we should instantly see the all shape. Let me grab the harmonic here so I can rotate properly here for you. Okay, so now let's hide the wireframes of the spheres because we don't really need them anymore. All right, so now we start to see where in Terrence's sculptures, and that's where we get the all shape from. Grab one here. I think I got one in here. Right, so we can scale that up to those points there roughly. And this is also where the linchpin is derived from, is those points up here where those particles collect along the orange, be like an orange color. So that's also kind of where the colors come from. in terms of velocity. So let's turn off those spheres again so we can see how that all shape and linchpin emerge from those forces acting upon the particle systems. And it will just keep going through itself, repeating over and over, right? So essentially, what we're trying to get to in our paper and our work is using standing waves and wave functions instead of particles and balls, spinning around each other. So I think that could be part of where our confusion is coming from. We are thinking in terms of waves acting on particle systems to create geometries, as opposed to a charge in the point in the center and balls negatives spinning around it like the planetary Bohr, the Bohr type of model or the orbital type model. Rather, where I'm trying to go with more of a Dr. Milo Wolf and Gabriel Lafreniere's work, where it's all standing waves, energy wave theory, as per Jeff. Right? That's where we met and came together on that. We thought it was all waves. And so Terrence's sculptures, all shapes and geometry, are also, you have to see them and envision them as waves in motion, not actual solid pieces. Everything is in motion. Like he repeats this, all energy is waves, expressed in waves, nothing is curved. It's always in motion, in time. So this is a 4D sort of system, right? We have time in here and mass acting on the particle systems to create, I think, what mainstream would call electron clouds. So I hope that that gives a little more clarity to what we're discussing and the goals we have in mind. Now we like to try to describe that mathematically, if we can, with more detail using the fundamental forces in this type of model. And I can also show you while I'm here. Let me save this. I can show you the add-on that we did in Blender. Jeff programmed this, and it's called the Quantum Microscope add-on. And for an example, if we try to do the same model of 4 electron spheres and a positron in the middle, and we run that as the nucleons, all right, so it should be in there, I think. All right, so we can zoom in. And these are the values of the proton pentaquark 5-sphere configuration. 4 electrons, 1 positron. As we discussed, we probably need to change that name because it's reserved. So I think it might be just a matter of renaming things. But the forces and all the math is going to be the same. We just need to rename it so people can have a look at it from a different perspective. But again, this is all programming. It's not Jeff did it in Python script with the formulas used in the paper to try to simulate it, to see how it will work, if it's stable or not. And it's clearly stable. It comes out. If I get it color, I wonder. All right. So again, this is the red sphere in the model and the diagrams in the paper. That's the positive point center, 0 point positive center, I guess. And each of the blue spheres is your electrons with a repelling. So you have the attracting force and the repelling force at radius r. And the radius, we got to remember, is Planck. This is the Planck radius, Planck charge, Planck radius. And Jeff's the one to explain that probably better than I can, but that is the general idea of what we're trying to do here in the models. so we can try to prove it by simulation rather than experiment and have it hold and be repeatable and falsifiable by other people just to confirm whether we're right or wrong. So hopefully that clarifies things. And I look forward to our next chat, and hopefully we'll get another step closer next time we meet. So have a great week or whenever we meet next. And, cheers, guys. Bye.